this DNP3 protocol was developed by the electric utility industry, and it was intended to be an interim solution until the next specification, which was this IEC specification, was implemented. So one of the things about one of the differences between proprietary and open standards is that proprietary standards can be developed pretty quickly. If you're a single company and you get your engineers together and you tell them develop this protocol for us to use in our products, they can sit down together and they can work at it and they can knock it out and get it done. When it becomes an open standard, then you have several companies working together, several companies and organizations working together to develop these standards. And it takes a lot longer to do that. Just, different people have different inputs and different needs. And so, you have to develop a standard that's comprehensive enough to work for everybody's needs. And you have to coordinate all these different groups that are trying to put this together. So typically open standards tend to evolve more slowly than proprietary standards. And so a lot of times what you will see is that there's sometimes a reluctance to use the open standard because you can use your proprietary standard and you can do more with it more quickly than you can with open standards. So in this case, DNP3 is an open standard, but it was developed kind of quickly while they were developing a more comprehensive standard. So what's really happened in the industry is that a lot of people rolled out their DNP3 solutions. They've been kind of happy with them, and DNP3 became pretty widespread. Then this newer standard came out, and it has not been adopted as quickly just because DNP3 already works. People are familiar with it. They don't see enough advantage to moving to the newer standard. DNP3 is more robust, and thus it's more complex than Modbus. So it might handle things that happen with RTUs better, and it might have some features that you can't find in Modbus. So anyway, this DNP3 standard is something that I want you to know about. And let's just step back. So I've talked about a couple of the different specifications, and you'll have some reading material to go and kind of read up on these a little bit to get a feel for them. But I want to talk a little bit too about some of the mechanisms that happen in these protocols and how they work. So one of the primary differences in the way some of these protocols work, and actually some of the protocols can support both ways of doing it, is whether you're polling or you're getting reports by exception. Okay, so in the case of Modbus, you have a master device on the network, and then you have you can have multiple slaves, one or more slaves. And so the master polls the slaves, and it goes to each one of them, each device on the network, and it says, hey, what's the value of this tag, or give me a block of tags. So you can say, give me the value of these 1,000 tags starting at this address, and the device will put together that response and it'll send it back. Okay, and so that's an example of a polling loop, where the polling loop, I send the request, and the device sends the answer. Okay, so another way of doing this is with exception reporting. So here's the thing: this device, let's say this device has 1,000 tags in it. But at any given time, if I'm polling this once a second, I might be asking for all these values, but only, say, 200 of them might have changed since the last time you polled me. And so there's a lot of data going over the wire. It doesn't necessarily have to go over the wire. So what we'll do is we have an option here in some systems to report by exception. And report by exception, what happens is the master says, I'm interested in this group of tags. Tell me whenever they change, and then a device will sit here, and every time they change, I'll say once a second, it'll report back once a second with the values that have changed. And so the trade-off here is that I don't have to send the tags that haven't changed, and so I can sometimes reduce my network traffic by pursuing this type of reporting. So some protocols support this, some protocols don't. But if you ever see this, polling loop or report by exception, I want you to know what it means. So to wrap this up and put it all into one coherent picture for you, hopefully. So now we know about networking and we know a little bit about protocols. And so now we understand the way this works is that up here on the up here I'm going to have a server or a computer program running on a computer, and this thing is going to have a let's say it's got an address here of using the same old 1.100, and then my PLC down here can have its internet address. Let's say this is 2.10, and so if this device needs to go and find out what values it's reading for its instrumentation, it will by the address say Mr. PLC at 192.168.2.10, give me the values of these tags, and it will use a protocol. Let's say it's DNP3 for this example. It will use the DNP3 protocol to send packets to this PLC. The PLC will read the packets, determine what tags have been specified, and give the answer back. So we've got our network layer and our addressing, and then we've got our application layer here, our protocol that we're talking. Okay, and so even though, say right here, we may be using Ethernet and DNP3, this RTU may be talking to a device here. This may just be serial, right? These may be serial on an RS-485 link. And so I may have these three devices on my RS-485 link on my RTU, and maybe they're speaking Modbus. Okay, and then this RTU could be speaking DNP3 back to the master. So you'll see mixtures of protocols, and so this is an open protocol, this is an open protocol, but I could also have maybe this is a Siemens RTU down here, and so maybe it's speaking S7 to its devices. So I could have an RTU here with multiple PLCs. Maybe these PLCs are all connected together through Ethernet, speaking S7 down here, the proprietary protocol. This RTU aggregates all the information, and then through the open protocol DNP3 gives me back my tag information. So in any given SCADA network, you're going to see multiple protocols and networking topologies and serial links. They're all going to be mixed together because as our electric grid grows, maybe maybe I had a certain brand of RTU or a certain model of RTU that I put out that used a Siemens PLC and Modbus here, and then later on I go put in another RTU, but now Siemens is selling a newer PLC, and so I've got a newer PLC with maybe some different communications protocols over here, and so your networks are never homogeneous. People try to standardize. They'll say, oh, we're going to use all Siemens equipment, but even if you do that, say over the course of 10 years, the chances are the PLC that you used in this RTU is not the PLC that they're selling today. And so the protocols that you choose and the instruments that you're talking to and everything are all going to change. And so you'll have older legacy equipment that may do it one way and newer equipment that does it a different way. But the idea is that, using your little toolbox of your open protocols and, your tag names and all this other stuff, you're able to communicate effectively between the old and the new equipment using very similar mechanisms. And so that helps you get past the point, they're not completely different. There's still some commonality. So we're going to talk a little bit about system integration in the next lecture, and so that covers a little bit more about this, how to link together heterogeneous networks and how to get the data from here. So let's say there's something happening here, and I've got an engineer up in the office that's doing a study of these devices, and so he needs to get historical information and all that. So how does the data flow up through this system and then out onto the corporate network safely and effectively so that people can do the things that they need to do out here without there ever being any danger of them affecting the operation of my network down here. So that's what we're going to talk about next.